Alright, grade 8s, here's today's quick lesson. Let's play a game. Let's talk about what would happen if we were playing a game where we first had to roll a dice and then we had to toss a coin. What is this set of possibilities for the first step? Well, when we're rolling a dice, we have 6 sides to our dice. So we have omega equal to 1, 2, 3, 4, 5, and 6 because we have 6 possible outcomes. And then we're going to toss a coin. And when we toss a coin, we know that we have 2 outcomes. We can either have heads or tails. So the notation that I would use would be omega equals h comma t, where h is heads and t is tails. So if we were to play this game and we were to roll a dice and then toss a coin, there are going to be a certain number of possible outcomes when we do the 2 in sequence. So for example, I could roll a 5, then get a heads. Or maybe I could roll a 4 and get a tails. So when we have 2 simple random experiments that we do in sequence, i.e. step 1, step 2, this is a compound experiment and it's still random. So if we roll the dice, toss the coin, and record the outcomes, in this unit what we're looking for is to be able to answer the following question. What is the complete set of possibilities for this game? Well, obviously we have 6 possible outcomes times 2, so there should be 12 altogether. And so if we were to write it out and visualize it, our set of omega would be equal to these 12 sets of answers. You could roll a 1 in tails, a 2 with tails, a 3 with tails, a 4 with tails, and so on, or you could also roll each of those numbers and then a heads. So we get a total of 12 possible sets of answers. So what would the probability of your guess being correct? Well, you would have a 1 in 12th chance of guessing the correct sequence. So when we're looking at the number of outcomes in a compound random experiment, there's 2 different ways that we're going to be able to visualize and find the answer. So let's walk through an example just to kind of explain how it works. Let's take a look at a pretend menu at a cafe. So let's say we were going out for lunch, and at the cafe you have only 3 choices. You can have pasta, chicken, or fish. And the main dish is always served with a choice of either soup, salad, or bread, and then you have a choice of coffee, tea, or a soft drink. So the question is, how many different lunch options are there? And what we want to really know is how we can calculate them. So the first way that we can do this is let's draw a diagram to help visualize the different possibilities. So if I write down my choices, I had pasta, chicken, and fish. And then with each of these dishes, I was able to then choose a side of either soup, salad, or bread. And then I was able to choose either coffee, tea, or a soft drink. So using a tree diagram, I can very quickly map out and take a look and help myself visualize the different possibilities. Pasta, soup, and coffee, pasta, soup, and soft drink. Maybe I'm going to choose pasta, bread, and tea, but at least I can visualize them all down the side. So we have all of these different outcomes that would be part of our omega or our subset of answers. This can get quite tedious if we're drawing this out in order to do more complex calculations. So I'm going to show you a shortcut that we call the multiplication rule that's going to help you. So step 1, we had 3 choices of main dish. In step 2, we had 3 choices of side dishes. And in step 3, we had 3 choices of beverages. And so my possible outcomes, I just use this multiplication rule. If I multiply 3 times 3 times 3, I get 27. So if I were to go back and count all of the different outcomes that I've listed here using my tree, there should be 27 possible outcomes. So just to recap the number of possible outcomes, there are 2 main methods to help you determine them. First method, draw a diagram or a table to help you visualize the possibilities, then simply count the outcomes. The second method is to use the multiplication rule, and you'll count the possibilities. And in this works really well. So when you have an experiment that is carried out over several steps, you count the possible outcomes at each step, and then simply multiply them together to find the total number of possible outcomes.